For this week's in-class activities, as well as for all of your future programming assignments in C, it will be very helpful to have some familiarity with a C debugger. To that end, I'd like to use the program we wrote for the last video as an example to show off a couple of different options for debugging in C. The first of these is debugging on the command line with the program GDB, the GNU debugger. In order to use any sort of debugging in C, we need the compiler to include debugging information in the executable. We do that using the -g flag when we compile. And we can still use any other arguments to the compiler, like specifying the name of the executable with -o. And so now I've created an executable from our shout.c program, and I could run it like I was running the executable before. But if I want to inspect what's going on during the execution of this program, I can use GDB. To run the debugger, you type GDB and the name of the executable. And now we have a prompt that indicates that we are operating in the debugger. To run our program, we type run. And GDB ran the program for us, and we see the output of our program printed. We didn't give any input or output file names, and so we got our error from the top of main. And then GDB tells us that the program exited with an error code. So if we want to run the program using command line arguments, then we type run followed by the arguments that we would have given on the command line. So up here I ran our program and then these command line arguments, and so I can give those same command line arguments to the run command inside GDB. And if I do that, GDB ran the program and tells us that it exited normally. So far, this is no more useful than just running the program on the command line. But the real value in GDB is that we can pause the program's execution anywhere we like. For example, we could pause the program's execution before it starts executing this while loop to read the file. We could do that by putting a breakpoint on line 35, which will cause GDB to execute everything before line 35 and then pause when it gets to that line. We do this with the GDB command break and then a line number. And now, if we run our program, GDB pauses at breakpoint 1 in main. And at this point, we can, if we want, print out the values of some of the variables in our program. For example, we can print argc. And as expected, based on the fact that we got past all of our checks, argc must be 3. Similarly, we could print the out file, but out file isn't the string. The string is one of the elements of argv. What I printed was the file pointer variable, and what it printed was a memory address, because pointer variables store memory addresses. If I wanted to print argv of 1, then it will tell me, well, that is a character pointer, so it tells me both the address in memory, but it's also smart enough to know that character pointers are strings, and so it also shows me the string that is stored at that location. I can now execute the next line of the program with the command next. And now it tells me that we're on line 36. And so if we were to print line, it should now contain the text that was read by the first call to fgetS. If we had instead printed the line before calling fgetS, we would have just gotten garbage data, whatever happened to be in that array before we put any data into it. In fact, let's demonstrate this by using the run command again to restart from the beginning. It'll ask us, are we sure? We're in the middle of debugging. Do we really want to start back from the beginning? Yes. And now we've arrived at line 35, where we have not yet executed this line calling fgetS. And so if I were to print line, that just has a bunch of garbage data, whatever happened to be in memory when our program allocated that to be where the array is stored. But when we execute the next line and print, now that array has been filled with the data that was read from the file. Another thing that we can do instead of breaking based on a line number is we can put a breakpoint at the start of a function. So I can do break capitalize to put a breakpoint in that function, and it tells me that it's on line 11, which is in fact the start of that function. And so now, if I continue execution, execution is currently paused on line 35, but if I let it run, it will execute until it gets to the next breakpoint, which is in the capitalize function. So I'll do continue, and now it says we're at breakpoint 2 in capitalize. And we can see the state of this function by printing out our variables like letter. But we can also print out more information with info locals to see all of the local variables, and info args to see all of the arguments to the function. In this case, that didn't give us a lot of extra information since this is such a simple function. But if we had a more complicated function that declared lots of local variables or had lots of arguments, we could see them all at once with these info commands. We can also see where we are in relation to other functions in the program by the where command. So where shows us the entire function stack, all of the functions that are executing on the way to getting us here. In particular, we start from the main function, and then the main function called the capitalize function, which means that when we are in capitalize, main is paused, waiting for a return value from capitalize. And so, on the function stack, we have the main function, and then on top of it, the capitalize function. And even though we are paused in capitalize, if we are interested in finding out the local variables from main, we could go up 1, and it now tells us instead of being in capitalize, now it's giving us the context in main, and we could do info locals for main, and in main at this point we have a local variable I, and we also have the in file and the out file and the line. If we continue from here, we end up back at breakpoint 2 in capitalize. At any time in GDB, you can use Control-D or type quit to exit, and it will often ask you to verify, and you can say yes to get back to the terminal. Another way that we can do debugging is within VS Code. On the side panel here, we have the Run menu, and we can go to the Run and Debug option. And if you have installed the C and C++ packages for VS Code, which you definitely should, then you will have the option to debug a C or C++ program. So I'm going to choose the GDB backing for our debugger in VS Code, which means it will be doing the same thing that we just saw on the command line, but it will be in a much nicer interface that's inside of VS Code. If you're running on Windows, though, getting GDB installed is a pain, and so you might choose the other option. And so now I'll select the default configuration, and at this point it takes me to a launch.json file. This file is the configuration for the VS Code debugger, and if you want to come back to this file later, it lives in the .vscode directory that was created inside the current folder, and then we have the launch.json file. And the reason that it sent us here is that we need to tell the debugger how to run our program. So there are 2 lines that we need to modify here to make the debugger run like GDB in the command line. The first thing we need to do is tell it what is the executable for our program. We'll delete this explanatory text so that we have just this workspace folder variable. And so that evaluates to the current folder that we're in. And so in that folder, the executable is called shout. And so I will replace a.out with the name of that executable. And so now it's saying that we want to debug this executable. Then, like we did for command line GDB, we also need to tell it what arguments we want to run the program with inside the debugger. And so this args, we need to give it 2 strings for the input file, holmes.txt, and the output file, out.txt. And now it will correctly run GDB for us. So if we come back to our debug menu, then we have a green play button here that starts debugging. If we run that, then we get the same message we did, that the program exited normally with code 0. So that's what happened when we didn't have any breakpoints in GDB. So now let's go back to our code and add some breakpoints in VS Code. So we add breakpoints in VS Code by hovering to the left of the line number and clicking to get a red dot. So we will put a breakpoint again on line 35. And let's also put a breakpoint in the capitalized function. This time let's put it inside the if statement so that we'll only break if we got a lowercase letter. Now that we have some breakpoints, we can start debugging. And we are paused on line 35 of our program. And on this left-hand side, we have information about the local variables and the function that we're currently executing. So we see, for example, that argc is 3, and argv only shows us this pointer value, but we can do exactly what we would have done in GDB on the command line over here, using, as it tells us, exec to execute a GDB command. I shouldn't have used the quotes. And now we get the same output as we got from GDB, both the pointer and the string that's located there. We also have this menu up here, which allows us to do, we can use the step to execute one line of code, just like next on the GDB command line. And we can do next again to go to the next line of code. If we hit the play button, that's the same as continue from the GDB command line, and so that will run until we get to another breakpoint. And eventually we hit the breakpoint inside our if statement in capitalize. And now note that the call stack has capitalize and main. And if we want to, just like we did with the up command, we can switch context between these to look at what are the variables in main, and that'll show us the local variables for main, or in capitalize, what are the local variables. And the first time that we're in this if statement is on the first lowercase letter of the text. So we now have two different ways that we can do debugging of our C code, and this will be helpful for a number of our in-class activities and for all of the homework assignments that you will be programming in C. Again, I encourage you to take a look at the Dive into Systems reading on GDB, which has much more detailed explanations of commands and shortcuts that you can use in the command line version of GDB. And as we saw, you can also use all of those commands in the VS Code debugger.